Alright guys, this is going to be your review for your quiz on Monday that's solving exponentials and logarithms. You have 30 questions. I am just going to do the evens to make this video a little bit shorter. And if you notice, all the ones that are next to each other are like pretty much the exact same problem. So I'm just going to do the evens, starting with number 2. To solve for x here, I have a logarithm. I only have one logarithm, so I don't have to combine anything or condense. So I'm going to go ahead and bring in a base of 6 to both sides. So I do that because that's the inverse and those cancel out. So now I have x plus 4 equals 6 raised to the power of 3, which is 216. All right, and then my last step is just to subtract 4. So 212 is my answer. Okay. When we have logs, it is always a good idea to make sure that my answer, when plugged back in, does not give a negative, and right here we don't, so we're in good shape. All right, the next one, number 4. There's 2 ways to do this problem. The first way you could do it is you could just go ahead and bring in a base of 5 to both pieces to cancel out my log. So then we have x cubed equals 125, and then you would take the cube root of both sides to get x equals 25. Okay. The other way you could do it is you could actually drop the power to the front of the logarithm and then multiply it. So 3 times log base 5 of x equals 3. Then I'm going to divide both sides by 3. I'm left with log base 5 of x equals 1. Oh, this answer right here is wrong. Should just be 5. Now I bring in a base of 5 to both sides. That cancels, and we have x is equal to 5, just like before. All right. Number 6. We're going to bring these two together. Since I see a minus sign, I'm going to use my property of dividing. So this becomes log of 8 divided by x equals 4. This is a common log, which means my base is 10, so that's what I'm going to bring to both sides. And I have 8 over x equals 10 to the 4th, which is actually 10,000. All right, now I need to multiply by x. So 10,000x, and now I'm going to actually divide by 10,000. So 8 over 10,000 is equal to x. This decimal is, it says 8 times e to the negative 4. That means you have, you move your decimal backwards 4 places. So that's the same thing as saying 0.0003. Right? Same thing. All right, number 8, I have 2 exponentials. Okay, I can rewrite these to both have a base of 3. So I know 9 is 3 squared. Okay, and I also know that 243 is 3 to the power of 4. All right, raised to the 2x plus 3. If you weren't sure about that, you know 9 is 3 squared. So when we give you 2 of these equal to each other and they both have a variable in their exponent, okay, you can change their base. So you know this is 3 squared, so that should be your clue that this has to be 3 raised to something. Okay. Once I get them to be the same, I'm going to multiply the exponents together and make them equal to each other. So 2 times x is 2x. And then 4 times 2x equals 8x, and 4 times 3 is 12. Okay, now I'm going to subtract 8 to give myself negative 6x equals 12. And then we're going to divide by negative 6 to give me x equals negative 2 as my answer. All right. Number 10, we are simplifying now. I see natural log and e. Remember, natural log, guys. Remember, we talked about how natural log is a log with a base of e. So to see natural log e, I'm actually looking at log base e of e to the negative 10x. Okay, that's why they're inverses, because look, their bases are matching. So So that is why I get to cancel those two out whenever I see them next to each other. All right, so this simplifies to just negative 10x. All right, number 12. Again, I see natural log and e together, so we're going to cancel those out. I'm left with the 2, I'm left with the 3, plus sign in the middle. All this does is simplify to 5. Okay, I'm not going to multiply them because I canceled out the logs. There's no logs left to do log properties with once they're canceled out. Number 14, same situation. I see an e and natural log connected again. So I'm going to take those away. I'm left on this side with the 4x, left over here with the 2x. Add them together to get 6x. There's something in my way of connecting my e and my natural log. So I'm going to rewrite this because since I have a 2 multiplied to a log, I actually get to use power property. Take this 2 and move it up to an exponent. This is going to become e raised to the natural log of x squared plus e raised to the natural log of 2 to the power of 4. All right, so cancel my pieces out. This is going to be x squared plus, and then 2 to the power of 4 is 16. So my answer here is x squared plus 16. Okay, going to the back. 18. Again, 2 ways to do this problem. I'll show them both to you. The first, microphone dropped. There we go. The first way we're going to do this problem is you can just go ahead and bring in a base of 2. Okay, so you can have 2 raised to log 2 and 2 to the 4th. That cancels. Now we have x plus 4 cubed equals 2 to the 4th, which is going to be, was that 16? We just did that. Now we have to do the cube root of both sides, which that's not going to be a pretty number. Remember, in our calculators, we can push our math button. Go down, here is cube root of 16 equals 2.52. So x plus 4 equals 2.52. And then you're going to subtract 4 from that. And we're going to get x is equal to negative 1.48. Now I see a negative, so I have to be careful. I plug it back in, make sure it works. This one is okay, because when I plug it back in here, negative 1.48 plus 4 brings me back into the positive. Okay, so this answer is going to work, and I will have a solution. Okay, you could have also taken your power and dropped it to the front like we did previously. Right, so I'm going to do that over here. So I'm going to make it 3 times log base 2 of x plus 4 is equal to 4. I'm going to divide both sides by 3. So now I have log base 2 of x plus 4 equals, I'm just going to leave it as 4 over 3. Okay. Bring in a base of 2 to both sides, cancel that out. Now I have x plus 4 equals, well, 2 raised to the 4 divided by 3 is 2.52. That should look familiar. Right? That's what happened right here. And then we subtract 4 to get, once again, x equals negative 1.48. So whichever way you do it, if you want to move the exponential down first and then divide to get smaller numbers, or if you just want to bring in the base right away, then it'll end up being a root. That's fine as well. Whichever way you want to do it. All right, number 20 is one of my favorites because we get a factor. Okay, I know that because I'm multiplying plus sign in between 2 logs, right? We're going to multiply, so we're going to have log base 8 of x squared minus 2x equals 1. Bring in my base of 8 to both sides, so that cancels. Now I have x squared minus 2x equals 8, and because of that x squared, only way to solve a quadratic, well, right now at least, we're going to factor. So I'm going to subtract it over, come up here, to give me x squared minus 2x minus 8 equals 0. Think what multiplies to give you negative 8 and adds to give us negative 2. Right, that is going to give me be negative 4 and positive 2. And then last but not least, we are going to solve each of these. So we have x equals a positive 4 and x equals negative 2. Again, it is a log. Make sure they both work. And actually, when I plug them back in, 4 is fine, positive, positive, right? 4 minus 2 is still positive. But this guy, plugging negative 2 back in, makes both of these negative. So negative 2 is out, and just 4 is my answer. Okay. On to 22. 22 and 24 are very much the same problem. You have an exponential where you cannot make your bases the same. Okay, so let's do 24. Okay, I'm going to bring in a log with a base of 3. And when I do it, I have to do that to both sides. So they both have a log base 3 in front of each of them. I do that because on this side, they will cancel. I'm left with x plus 2. Okay, log base 3 of 17 is a number, right? So remember, we are going to go to math, log base. It is base 3 of 17 to give me 2.58. Remember, if you can't use that function, you can do change of base. You would actually have to push this button. You have to push log of 17, and then you would divide it by log of 3, and you'll get the same thing. So if you're not able to do this in your calculator, you can do it this way. We still get 2.58. And then our last step is to subtract 2, so we get just 0.58 as our answer. All right, number 26. Natural log of 12 minus natural log of 2x equals 9. I see 2 natural logs. Your first instinct is probably to bring in the e, but you can't do it yet, okay? You have 2 logs. You have to make it just 1 log first, okay? And we do that with our properties. I see a minus sign. I will divide 12 by 2x. So I end up with natural log of 12 over 2x is equal to 9, okay? 12 over 2x simplifies. So that's natural log of 6 over x equals 9. Now I can bring in my e. Okay, so I have 6 over x equals e to the 9th. Multiply by x. So e to the 9th times x, then divide by e to the 9th. So when we do that, we get 6 over e to the 9th, and that equals x. That is our final answer. Remember, keep it in terms of e, okay? Leave the e in your answer. All right, 28. Again, it's solving, but I see an inverse property happening, e and natural log. I'm going to go ahead and cancel those out. Now we have x cubed equals 1,000. To undo a power of 3, I need to do a root of 3 to both sides. Leaves me with x equals 10.